Okay, this is the second video on Arduino Serial Terminal. So the first video, we established a connection. We kind of configured the settings of the terminal. So checked, no check, 9600. Okay. User can enter inputs in this field and then click the send button. Okay. The message coming from the board will be displayed in this field. So let's try to do this. Suppose I enter A, lowercase a, I sent. Okay, I sent, I get two messages, 97 and 10. Okay, so let's explain why we get two instead of one value. Okay, now the reason we get 97 is because we're trying to print out the value in decimal. Okay, A lowercase hexadecimal value or the ASCII value of lowercase a in decimal is equal to 97. Okay, so if you go back to check the ASCII table, lowercase a is 97 in decimal. Now what about this 10? This 10 represents the send button, because every time you want to send something into the Arduino, you need to tell the Arduino this is the end of my message. And for now, the send button will tell you this is the new line ASCII. So 97 is the data coming in, 10 is new line coming in. So these two combined tells the Arduino, I want to send you a data which is 97, and I'm going to send you a 10, which is the end of the message. Okay, all right. If you do another one, B, in theory, ASCII value of B is 1 plus ASCII value of A. So the expected value should be 98 and 10. So let's do that. Send. Exactly 98 and 10. So 10 is new line or the end of my message. Okay. And 97 is the data. And 98 is also the data. Okay. So if you click on this, you can play with the settings. You can say, I don't want to send additional message to terminate my message. You can change this to no line ending. So now let's try it again. A, send. See, you do not see 10 anymore because the button send no longer sends additional bytes to terminate the message. Okay, if this is the behavior you want, you can always configure under this pull down menu. Okay, so B, send. Okay, if you want to send multiple values together, you can just enter everything in one string, A, B, C, D, E, F, G. And then if you click send, all of them will be sent in the order of entry. So the first data is going to be sent. It's A, followed by B, C, D, E, F, G. Sent. So we have A, B, C, D, E, F, G. Okay? All right. Let's clear output. Let's try to modify this example and use other print format. So going to the Arduino Serial documentation page. Let's click print ln. you can see that the print supports decimal, hex, octal, and binary. Okay. Default is decimal. Now, we don't really use octal system right now. So let's try hex and binary. Okay. So let's look at the code. We can copy and paste line number 21 into hex and binary. Okay. Let's do a file, save, sketch, verify and compile. Sketch, upload. Open up the terminal. Let's see what we have. A. Sent. 9661. So 96 is decimal, 61 is hex, and the binary combination is 1100001, which is 61. Okay. Let's try B. Sent. 98, 62, and 1100010, which is the binary combination of 62. Okay. So let's close this terminal. So the Arduino terminal supports read, supports print. A print always print out the ASCII. If you want to print the raw data, say you want to print out the data using binary only, you cannot use the print anymore because the print always deal with ASCII. There's a separate function called write. So what the write will do is the write will write the binary data. So if you are interfacing with external components and the component only accepts ones and zeros, the component will not deal with ASCII, then you should use the write instead of the print. Okay, the print is for human readable message. Write is for hardware binary values. Okay, it supports multiple formats. Format number 1, you can write a value 1 byte only. A string of values means multiple bytes, or array of bytes. So you can put all your values into array and then send the array through the serial terminal. Okay. Now this is very useful if you want to interface with hardware. However, if your applications primarily deal with human interactions, keyboard, okay, message, the calculations, looking at what's going on with variables and registers, the print or the println is the one you need to use. Okay. All right. So go over these functions on your own time and try to use whatever you feel comfortable. Okay. When you develop applications, your goal is not to use every single function that you can use. The goal is to use the functions to complete the task, and you should only use the functions as you feel comfortable with. Okay? Alright. So let's summarize what we just did. We talk about incoming serial data. So we need to check if any data is available in the buffer. Then you can get the bytes, decimal, binary, or hex, or you can get it as ASCII. Outgoing data, same thing. You can have the bytes, the binary, the hex, or the ASCII. Okay. So going back to our example, you can see that this is the typical code for Arduino serial terminal. Okay. Now this terminal is disconnected automatically if you unplug your board from your computer, and it will not reactivate it on its own if you reconnect the board. So before finishing your applications, the first thing you should do is you should close this terminal. So next time you want to open it, it's going to open from a not connecting status to connecting status. Okay, so this is the part you need to do every time you want to run your application. Close it first, run your new application, and then open it. Okay, so this concludes our second video on the Arduino serial terminal. Thank you.